So today is day 2 of solving blind 75 sheet, and the question is your best time to buy and sell stock. It's a pretty easy question. You are given an array prices where prices of I is the price of the given stock on ith day. So basically here is an array 715364, and 7 is the price of stock on day 1 is the price of stock on day 2, and so on. We want to maximize our profit by choosing a single day to buy stock and choosing a different day in future to sell that stock. So what is the basic logic behind the selling of stock? So you buy on the day where the stock price was less, and then you sell it where the stock price was the highest, right? So here, suppose if you bought the stock on day 2 where the price was 1, and you sold it on the day 5 where the price is 6, so you're going to make the profit of 5, right? That is the maximum profit you achieved. So what things did you consider while thinking of this logic? So we basically have to keep the track of the minimum price, all right, so that we can purchase on that day. And after, once the minimum price is, once we have the minimum price, and then we are going to look for what is the maximum value after the minimum price. It is 6. So 6 minus 1 is equals to 5. All right. Now, if on another day after this, suppose the minimum price is 0. I know it's not possible for a price to be 0, but let's suppose there is a price that is less than 1, 0. So that there is 0, then we are going to update our minimum price to 0, and then we are going to look for the next maximum value. Suppose there is existing a 6 after 0 also. So 6 minus 0 is 6. So maximum profit will become 6. All right. So we have to keep the track of two variables, that is minimum price and a maximum profit. Let's see. Int minimum price is equals to, let's say the first price is the minimum price, so the 0th price, I mean the price of day 1, and what is the maximum profit? Now here it is stated that if you cannot achieve a profit, then you have to return 0. So we are initializing the maximum profit with 0. In case there is no profit, then it is going to return 0 automatically. And when will the profit will be 0? So whenever, suppose these all are 7, all the values, the price never varies, the price is constant on every day, then we cannot make profit, right? And another point where the price is continuously dropping, decreasing, right, means our array is in descending order, then also we cannot make profit, right? So these are the two cases where the profit will not be generated. So we are traversing one time, it will go for linear time complexity for int I is equals to 0 and I is less than prices dot size I plus plus. So what are we going to do? We are going to update our minimum price if the price of the stock on current day is less than minimum. So basically minimum price is equals to the minimum of minimum price and the price of the stock on this day, that is prices of I. All right. And we are going to keep the track of maximum profit. So what is the maximum profit? The maximum value of either our past calculated profit that will be stored in the max profit variable itself, and what is the current profit, current day profit, possible profit of this day, that is the price of stock on this day minus the price of stock on the day on which we bought the stock. When did we bought? When did we buy? We bought on the minimum price where the price was minimum. So subtracted by minimum price. So that will take care of it, and we are going to simply return the maximum profit. Let's try this. So as you can see, it is passing all the test cases. So if you want to do a dry run, let's say first the minimum price would be 7 and the maximum profit is 0, and then we are going to update the minimum price. Actually we can run this from 1 also, right, because we have already stored the prices of 0 and minimum price. So let's run it from 1. So here the prices of I would be 1. All right, so what is minimum? 1. Prices of I is 1 and mean price is holding 7. What is minimum? 1 is minimum, so mean price is going to store 1. What is the maximum profit? 0, or the prices of I, that is 1 minus the minimum price. Minimum price is also 1 and price of I is also 1, so that is not going to change anything. Maximum profit will remain 0. Then at 5 we are going to keep the minimum price same because 1 is less than minimum price. I mean, sorry, 1 is less than 5. That's why minimum price will remain at 1. And the maximum profit will be, here the variable is holding 0 and prices of I minus mean price means prices of I is 5 and mean price is mean price is 1. So 5 minus 1 is 4, so maximum profit will be 4, and so on. It will continue till 6, where the 6, the maximum profit will become 5, that is 6 minus 1, right? So maximum profit will store 5. And then when the 4 comes, the minimum price will be compared first. Minimum of minimum price, that is 1, and prices of I, that is 4. So it will remain 1 because 1 is less than 4. And then maximum profit, max of maximum profit, which is holding 5, and prices of I minus mean price. Prices of I is 4. 4 minus mean price is 1. 4 minus 1 is equals to 3. And the maximum profit will also remain 5 because 5 is greater than 3. And then the function will return maximum profit. All right. So here's how it is working. And you can also solve it in brute force approach using 2 nested loops to check all the cases. But I think that is going to return in time limit exceeded error. That's why we've used this optimized approach. And it is working perfectly fine. All right. Let's see these solutions. So they are also the same, as you can see. Right, they're exactly the same, right? They've just defined the size before. They're exactly the same. So this is the most optimal solution. All right, we will meet tomorrow. Thank you.